seen in the last class what is the difference between the ideal op amp and the practical op amp. Ideal op amp and the practical op amp. So here we are having infinite. So the differences between ideal op amp and the real op amp is for the ideal op amp we are having infinite open loop gain and infinite bandwidth and infinite slew rate and the infinite input impedance and zero input current and zero input offset voltage and zero output impedance, zero CMR, that is noise rejection ratio is uh, zero noise and the infinite CMR. For the real op amps, that means the practical op amps, they have finite open loop gain, finite bandwidth. So when ideal is these are the infinite values. For the practical op amp, there will be some there is no infinite, there should be the value present when it will be acts like as a practical op amp, finite bandwidth, finite slew rate and the finite input impedance and so little input current and the small input offset voltage. So in case of the ideal it will be zero, there is no input offset voltage. For practical it is a small output impedance and a small noise and the finite common mode rejection. That means apart only the input and output and the so those values are zero in ideal op amp and the remaining are infinite. But in real, so those are apart from the input offset voltage and the output offset voltage and the remaining are finite and the remaining have small values in a practical op amp. So here basically the op amp is a multi-stage direct coupled high gain amplifier and this may contain single or double or quad ampere. So the features of op amp are mainly high input impedance. So the input impedance will be very high input impedance and the CMRR common mode rejection ratio is very high and the high bandwidth low output impedance. So if the all ICs are manufactured with cascaded amplifier, a small voltage is required for working as a semiconductors are used in room temperatures is usually to get extra voltage. So while operating using op amp, offset null is connected, so has to make these voltages are zero. That means if you are manufacturing ICs, so there will be we have to use a cascaded amplifier to produce a small voltage for working as a semiconductor. Semiconductor is nothing but so semiconductor we are having different type of semiconductors, that is internal semiconductor and the external semiconductor. So internal semiconductor is nothing but a pure semiconductor. Whenever we having silicon and the germanium, these are pure materials, so that type of materials we can call it as a internal semiconductors. And the external semiconductors are nothing but, so if you are adding some impurities, if you are adding some impurities to that pure silicon and germanium, so that will acts like as a external extrinsic semiconductor, intrinsic semiconductor and the extrinsic semiconductor. So the main difference between intrinsic and extrinsic semiconductors are we have to add some impurities to um, intrinsic semiconductor. That is the adding of impurities is nothing but doping. సో మనం ఎప్పుడైతే డోపింగ్ చేస్తామో ఒక ప్యూర్ ఫర్ ఎగ్జాంపుల్ మనకి వాటర్ ఉంటాయి, వాటర్ ప్యూర్ వాటర్ ఉన్నప్పుడు దాని క్యారెక్టరిస్టిక్స్ అండ్ దట్ పారామీటర్స్ సో ఒకలా ఉంటాయి. సో ఒకవేళ మనకు ఆ ప్యూర్ వాటర్ కాస్త ఆ బ్లూ వాటర్గా రెడ్డిష్ వాటర్గా కానీ ఈ హోలీ మనం ఎప్పుడైతే హోలీ ఫెస్టివల్ చేసుకునేటప్పుడు సో వీఆర్ యాడింగ్ సమ్ ఆఫ్ ద కలర్స్ టు దట్ వాటర్. సో ఎప్పుడైతే మనం ఆ కలర్స్ అనే వాటర్కి యాడ్ చేస్తామో దెన్ దట్ విల్ బి converted as some nature. That means there will be difference between the normal water and the added color water. సో మనకు ఆ రెండింటి మధ్య డిఫరెన్స్ ఏంటో మనము అబ్జర్వ్ చేస్తాం. సో ఈ ఎప్పుడైతే ఈ కలర్స్ యాడ్ చేస్తామో అప్పుడు మనకి డిఫరెంట్ స్మెల్ అనేది వస్తుంది, డిఫరెంట్ వాల్యూస్ కూడా ఉంటాయి. సో ఇన్ ద సేమ్ వే ఏ విధంగా అయితే మనం అలా చేస్తామో ఆ సేమ్ వే మనం ఎప్పుడైతే వీటికి ఉన్న ప్యూర్ మెటీరియల్స్కి డోపింగ్ చేస్తామో, దట్ మీన్స్ యాడింగ్ సమ్ ఇంప్యూరిటీస్ అని యాడ్ చేస్తామో, సో అట్ ద టైమ్ దట్ విల్ బి కన్వర్టెడ్ యాజ్ ఎక్స్టెన్సివ్ సెమీకండక్టర్. సో దట్ ఎక్స్టెన్సివ్ సెమీకండక్టర్ విల్ యాక్ట్స్ లైక్ యాజ్ ఏ సెమీకండక్టర్స్గా వర్క్ అవుతాయి. సో ఎప్పుడైతే సెమీకండక్టర్స్గా వర్క్ అవుతుందో, సో దట్ విల్ బి యూజువల్లీ టు గెట్ ఎక్స్ట్రా వోల్టేజ్ సో వైల్ ఆపరేటింగ్ యాజ్ ఏ ఆప్ యాంప్. సో ఆప్ యాంప్గా వర్క్ అయ్యే ఛాన్సెస్ ఉంటాయి అన్నమాట. సో ఇది ద బేసిక్స్ ఆఫ్ ద ఆప్ యాంప్. అండ్ కమింగ్ టు ద క్యారెక్టరిస్టిక్స్ ఆఫ్ ద ఆప్ యాంప్, characteristics and internal diagram. So in internal, the block diagram of the op amp consists mainly input stage and the intermediate stage and the buffer shifting and the level stage. So that will have emitter follower with constant current source and the output stage. So an op amp is basically a direct amplifier having very high gain and direct coupled amplifier with high input impedance and low output impedance. So the op amp basically consists of 4 stages. One is the input stage, and another one is intermediate stage, and another one is buffer and buffer shifting and the level storage stage and the output stage. So here in the input stage is nothing but the input stage requires two input terminals with high input impedance and low output impedance. So these can be achieved by using a dual in balanced output differential amplifier. So the function of differential amplifier is to amplify the difference between two input signals. So whenever we are having V out is equal to V in minus V out, so that we will amplify the difference, that is V naught is equal to V1 minus V2. So whenever we amplify that difference, so that is called a difference amplifier. And this stage provides major part of the voltage gain. That is the input stage of the op amp provides more voltage gain for as compared with input. And the intermediate stage, so this output of input stage is directly connected to the intermediate stage. This is another differential amplifier with dual input unbalanced output amplifier. So that input stage done current provides such a high gain. In order to increase the gain, we go for intermediate stage. So the main function of the intermediate stage is to provide an additional voltage gain required. So the intermediate stage also amplifies the additional voltage gain. So that is the intermediate stage and voltage gain required as a cascade amplifiers called multi-stage amplifier. And third stage of the op amp is level shifting stage or buffer shifting stage. So the input stage amplifier and intermediate stage are directly coupled. So the DC voltage across the output of intermediate stage tends to rise above the ground. So these are different blocks involved in the op amp. So whatever it may be, each stage have a differential amplifier and each stage may amplify that values of the input and the difference of the different signal applied to the op amp. So that means every stage we have to improve the voltage gain. Whatever the each stage require the voltage, so that will be increased in every stage of the op amp, So finally at the output stage, so we have to multi-stage functionality. So the output which helps capability of the, so it will control the functionality. It will controls the functionality. So next, already we discussed in the last class the characteristics of the op amp. The characteristics are nothing but input offset voltage and slew rate, open loop gain, and the CMRR. So already we seen. So again, I will tell you clearly what is op amp characteristic. So first one is the input offset current. Input offset current. So that is nothing but it is the differential current that flows into inverting and non-inverting terminals of op amp with output voltage 0. It is the input offset current is nothing but it is the differential current that flows into inverting and non-inverting terminals of op amp with output voltage 0. So it is similarly like as a differential current. So that will be applied that into inverting and non-inverting terminals of op amp with output voltage 0 and is given as so the formula for this one is I input current is nothing but IB1 minus IB2 and the input offset voltage is nothing but so it is the voltage is applied to input terminals would reduce the op amp output voltage to 0. So that means if we are having any small amount of voltage at the internally within the op amp, whenever we are applying the voltage as an input offset voltage, so that will reduce the output op amp voltage to 0. So that term we can call it as input offset voltage. So it is the differential voltage that must be applied to input terminals to nullifying the output. It is given by V input offset voltage is equal to Vi minus Vi minus Vin. Next one, input resistance. So it is equivalent to resistance that can be either inverting or non-inverting of op amp with other terminals connect to ground. Other terminals connected to ground. So the input resistance is approximately for an op amp is 2 mega ohms. So it is represent as already I shown the equivalent diagram of op amp in the last class. So that is nothing but that may have input resistance and output resistance with a voltage source. So here the input resistance we can call it as so it is the equivalent resistance either inverting or non-inverting of op amp with other terminal connect to ground. And the output resistance is it is the resistance measured between output terminal of op amp and ground. So typically for a op amp 741 op amp the output resistance is 75 ohms and the CMRR is nothing but it is the ratio of differential gain to common mode gain, that is nothing but it is the ability of op amp to object the common mode rejection ratio is given by the common CMRR is nothing but the differential gain by common mode gain for an op amp CMRR is 90 decimals. So next one, power supply rejection ratio. So it is defined as the ratio of change in input offset voltage to the change in supply voltage. So power supply rejection ratio is nothing but so whatever the change occurred in input voltage, so that will changes the supply voltage value. So that factor we can call it as power supply rejection ratio. So it is in the formula PSSR is equal to change in input voltage by change in supply voltage. So whatever the input offset voltage changes, so the supply voltage is also changes. So that is the change in Vi by change in delta Vi by delta V. So next characteristics, thermal drift, the change in offset voltage and offset current due to the variation in temperature. So it name indicating thermal. Thermal means thermal is belongs to the temperature. So whatever the change occurred in offset voltage and the offset current due to variation in the temperature. That means whenever we are changing the temperature of the op amp or changing the temperature of circuit temperature, circuit or a room temperature, then whatever we are applying the offset voltage and the offset current is also changes with effect of a variation in temperature. So that term we can call it as thermal drift. Thermal drift. So offset voltage drift is given by change in input voltage by change in temperature, and offset current drift is given by change in input voltage by delta T. So and the output voltage swing, it indicates the values of positive and the negative saturation voltages of an op amp, and it never exceeds the supply voltages. It never exceeds the supply voltage. That means so we are having some positive and the negative saturation voltage, and it never exceeds the supply voltage. So whatever the voltage present, so that will not more than the applied input voltage. So that term we can call it as output voltage swing. Output voltage swing. So that is V naught equal to plus VCC or plus or minus VE. And the slew rate. So finally the slew rate is it is defined as the maximum rate of change of output voltage per unit, and it is expressed in volts per microseconds, and it is given by delta V naught by delta T. For 741 op amp, slew rate is 0.5 volts by microseconds. So these are some of the characteristics of the op amp. So characteristics ante, for example మన ఒక హ్యూమన్ బీయింగ్ కన్సిడర్ చేసుకుంటే, సో వాడు ఆ హైట్ ఎంత ఉన్నాడు, నెక్స్ట్ వాడి కలర్ ఏంటి, నెక్స్ట్ వాడి వాడి మెంటాలిటీ ఎలా ఉంటుంది, ఇలా ఏ విధంగా అయితే ఒక మనిషి గురించి మనం ఆర్ ఏదైనా ఒక ప్రోడక్ట్ గురించి, సో మనం ఒకవేళ ఏదైనా ఒక ఫ్రిడ్జ్ వాషింగ్ మిషన్ కొనాలంటారు, సో మనకి ఎంత కాస్ట్లో కావాలి, వాటిలో ఏమేమి ఫ్యూచర్స్ ఉండాలి, సో ఈ విధంగా ఏ విధంగా అయితే మనము ఎస్టిమేషన్ ఆర్ క్యాలిక్యులేట్ చేస్తాం, ఇన్ ద సేమ్ వే మనం ఒక ఆప్ యాంప్ దాన్ని కన్సిడర్ చేసుకుంటే జనరల్గా దానికి ఉండే క్యారెక్టరిస్టిక్స్, సో వాటిని అన్నిటినీ డెఫినిషన్ ఫార్మాట్లో చూసామన్నమాట ఇప్పుడు. సో దాని క్యారెక్టరిస్టిక్స్ ఏంది, దాన్ని ఏ వాల్యూస్ పైన ఈ ఇన్పుట్ ఆఫ్సెట్ వోల్టేజ్ అండ్ ద అవుట్పుట్ ఆఫ్సెట్ వోల్టేజ్ అండ్ ద ఇన్పుట్ రెసిస్టెన్స్, పవర్ సప్లై రిజెక్షన్ రేషియో, థర్మల్ డ్రిఫ్ట్, వోల్టేజ్ స్వింగ్, సో ఇవన్నీ వాల్యూస్ అన్నీ ఎలా ఉంటాయి అనేది మనం థియరిటికల్గా నేర్చుకున్నాం. అంటే ఈచ్ అండ్ ఎవ్రీ క్యారెక్టరిస్టిక్స్ బిలాంగ్స్ టు ద ఆప్ యాంప్. సో దీస్ ఆర్ ద ఆప్ యాంప్ characteristics. So next one, so the op amp may works under open loop op amp without feedback and with feedback. So open loop op amp means so we're having without feedback. So that may works under non-inverting amplifier and inverting amplifier. So when we are connecting input signal to the non-inverting, plus is nothing but non-inverting and minus sign indicates inverting terminal. So here minus will be grounded and the plus will be connected to some voltage source. That means we are applying input signal at the positive terminal. So that is positive terminal is source, negative terminal is ground, and 0 degrees indicates there is no phase change. 0 degrees అంటే ఫేజ్ అనేది ఎలాంటి చేంజ్ అనేది అక్కర్లేదు. సో ఈ ఓపెన్ లూప్ ఆప్ యాంప్నే సో మనం నాన్ ఇన్వర్టింగ్గా యూజ్ చేసుకోవచ్చు, ఇన్వర్టింగ్గా యూజ్. సో ఎప్పుడైతే మనం నాన్ ఇన్వర్టింగ్ టెర్మినల్ కనెక్ట్ చేస్తామో అప్పుడు అవుట్పుట్లో యాంప్లిట్యూడ్ వాల్యూస్ అనేది ఇంక్రీజ్ అవుతుంది అండ్ ఎలాంటి ఫేజ్ అనేది చేంజ్ ఉండదు, ఫేజ్ షిఫ్ట్ అనేది చేంజ్ ఉండదు. అదే మనము ఇక్కడ ఇన్వర్టింగ్ యాంప్లిఫైర్ కనుక కన్సిడర్ చేసుకుంటే ఈ ప్లస్ అనేది గ్రౌండ్ చేస్తాము అండ్ ద మైనస్ సైన్కి ఇంకో వోల్టేజ్ సోర్స్, ఇక్కడ పాజిటివ్కి ఇచ్చాము, ఇక్కడైతే నెగిటివ్ దానికి కనెక్ట్ చేస్తాము వోల్టేజ్ సోర్స్ అనేది. సో ఎప్పుడైతే మనం ఈ విధంగా ఆప్ యాంప్ని యూజ్ చేసినప్పుడు, సో హియర్ ద ప్లస్ ఫర్ ద ఇన్వర్టింగ్ ఓపెన్ లూప్ ఇన్వర్టింగ్ యాంప్లిఫైర్, plus terminal is ground and the minus terminal is the source. So here whenever we are applying, the input voltage is amplified at the output, but the phase will be changes. The phase of the output of open loop inverting amplifier phase will changes with respect to 180 degrees phase change, 180 degrees phase change. So gain is very high, so unstable. So gain అనేది చాలా ఎక్కువగా ఉంటుంది కాబట్టి it is not in a stable condition, so it is in unstable condition. So this is about open loop inverting and the non-inverting amplifiers. Inverting and non-inverting, so modes of operation of op amp. So we can operate in inverting and the non-inverting mode as a open loop and the closed loop. So next we will see how the closed loop will works like. So here the closed loop op amp with negative feedback. So negative feedback, whenever we are connected as a negative feedback, it weakens the input signal and reduces gain. So it reduces the gain. So when the gain will reduces, therefore stability increases. So it will act like as a stable device. And the reduction in nonlinear distortion. So it will reduces the nonlinear distortion, and it will reduces the effect of input or offset voltage, and it increases bandwidth of the device, So those are the characteristics of a closed loop configuration. So here whenever we seen that is the closed loop inverting amplifier, so here we are having the source, so that will be inverting అని వచ్చిందంటేనే then we have to apply the input to the negative sign. అదే నాన్ ఇన్వర్టింగ్ అని వస్తే we have to apply the input source for the positive sign. సో ఇక్కడ మనకు వోల్టేజ్ సోర్స్ అనేది ఇన్పుట్ చేసాం. సో వీఆర్ కన్సిడరింగ్ input resistance. So this is a closed loop. Closed loop means we are having a feedback from inverting terminal to this one output terminal connect feedback untadi. So we have plus VCC for the power supply, plus VCC terminals and the minus VCC, and based on the here we are considering the open loop that is a virtual ground. Closed loop for the closed loop inverting amplifier, we are considering a virtual ground. So this is a closed loop gain, and negative sign shows the inverted output with respect to the input. సో మనం ఎప్పుడైతే వర్చువల్ గ్రౌండ్ కన్సిడర్ చేసుకొని మనం ఈక్వలెంట్ కరెంట్ as I of n is equal to, so I of s this current, so and IN and the feedback current. So ఈ I of n అనేది, సో ఈ వర్చువల్ గ్రౌండ్ పాయింట్ దగ్గర ఈ పాయింట్ దగ్గర మన కరెంట్ అనేది వెయిట్ పైన డిపెండ్ అయి ఉంటుంది, అంటే I of s and I of f. So if we considering based on the virtual ground, Vn and Vp is equal to 0. So this is for negative and the positive terminals of the voltage considered, we are assuming 0. So then so I of s is equal to, so I of s current equation V by R. I is equal to, from Ohm's law we know that V by R, so that is Vs by Rs. Then IF is equal to, IF feedback current will depends on output current by RF. So this IF will depends on V0 by RF. Then IN is equal to 0. So in this equation, if IN is equal to 0, then the IF is equal to IF is equal to minus IS. IF is equal to minus IS. Then, so we have to apply in terms of feedback current IS in terms of V by R. So then V naught by RF is equal to minus Vs by Rs, minus Vs by Rs. So whenever we are calculating V naught, so V naught, so then we get V naught is equal to RF by RS, RF by RS. So that is the formula for closed loop inverting amplifier, closed loop inverting amplifier. So next one, in case closed loop non-inverting amplifier, closed loop non-inverting amplifier. So here also same. So that is difference for the closed loop op amp is closed loop op amp. So here we are applying positive terminal to the voltage source. Voltage source is provided to the positive terminal of the op amp, and the negative terminal should be grounded. Negative terminal should be grounded, and feedback will be applied to the negative terminal of the op amp. So here also we are considering voltage virtual point. So based on this virtual point, we can calculate the equations. So that is Vp is equal to Vg. So that means P, the positive terminal voltage is equal to Vg, gate voltage, that means source voltage anukunte Vg anukunte, then Vn is equal to Vp is equal to Vg is equal to, so V naught into Rs by Rs plus Rf. సో ఈ ఉన్న ఈ వోల్టేజెస్ అన్నీ ఈ దీనికి ఈక్వలెంట్గా ఉంటాయి, దట్ ఈస్ V naught by Rs. సో దెన్ ద V naught ఈజ్ ఈక్వల్ టు Rs minus Rf by Rs into Vg. సో మనం ఇన్ టర్మ్స్ ఆఫ్ ఈక్వేషన్గా రాసుకుంటే ఆ ఈక్వేషన్ రీమోడలేట్ చేసి నెక్స్ట్ దీని ఎల్సిఎం కానీ తీసుకున్నామంటే దట్ ఈజ్ Rs by Rs ఉంది కాబట్టి దట్ ఈస్ 1 plus Rf by Rs. So in case of the closed loop non-inverting amplifier, that at the time the output voltage is equal to V naught is equal to 1 plus Rf by Rs into Vg, Rf by Rs into Vg. So this is the formula for closed loop operating amplifier. So next distortion. So we have this is the positive saturation value and the negative saturation value. So the gain will be increasing in a linear region. So whenever it will be enter into, that means it will crosses the cut-in voltage, so then that will be enter into the saturation, that is VCC is equal to plus 5 volts, VCC is equal to minus voltage. Here we are having the VD, the difference voltage, and the V naught. So the output voltage never exceeds the DC voltage supply of the op amp. So if that may excess the supply voltage, so then it will create some distortion, that means some noise within the op amp, so that is called distortion. And the few application of op amp is, so we can add this op amp as a summer or adder circuit. That means here we are having the inverting adder. So at the input we are adding V1, V2 and so on. So these all voltages will be added at the output of the op amp. So it is inverting closed loop op amp, inverting closed loop, because we are having the feedback from negative terminal to positive terminal. So we are having a negative terminal and the positive terminal feedback. So that is equal to V out is equal to minus Rf by V1 by R1 plus. So here that is nothing but here we are adding both the voltages and the resistance, and whenever we are adding both the voltages and resistance, we get the how much output voltage will be carried from this input to the output, from this input. So by operation of this circuit, we can call it as summing the input voltages or adding the input voltages So that's why you can use the op amp as a summer or adder circuit. So it is one of the application, and it also we can use it as a comparator. Op amp will also use it as a comparator. So here we are having two voltages. So here we are comparing the two voltages. That is V1 is greater than V2, or V1 is less than V2, or V1 is equal to V2. So at the time the output will decides Vs plus, Vs minus and 0. So that is V1 is equal to V2. That means, for example, V1 3 volts and V2 3 volts ఇచ్చామనుకోండి. So 3 minus 3 0. So we didn't get any output. So that means we can comparing at that time op amp will operating this condition. That is V1 is equal to V2, the V out is equal to 0. So then if the V1 is greater than V2, so V1 is 5 volts and V2 is greater than V2 is 3 volts. That 5 minus 3 is equal to, so we get 2 volts, that is Vs plus voltage. V out is equal to Vs plus voltage. And the next one, V1 is less than V2. So V1 is 3 volts and V2 is less than V. At the time the resultant V out voltage is equal to minus 2 volts. Minus 2 volts. We get V out is equal to minus 12. So that means based on this operation in this application, it compares two voltages and switches its output to indicate which is larger, and so this is about a comparator operation. So next integrator. So it can be op amp can also use it as an integrator and differentiator. So here in case of integrator we have to use at the feedback capacitor. So in case of the differentiator we have to use the capacitor at the series at the feedback resistor. So whenever we are exchanging these components, it can be acts like as an integrator and differentiator. So for this one, V out is equal to minus integral of 0 to t, integral of 0 to t, V in divided by RC dt plus V initial. So the V out will be, we will get integrated formula by using the virtual ground and the combination. We get this common, that is V in by RC dt plus V initial. So it performs the mathematical operation of integration with the output voltage is proportional to the input voltage over a time. So this is one of the application of integral. So op amp can be used as a summer or adder, and the op amp can be used as a comparator, or op amp can be used as an integrator. So you have to use in so many applications. These are some of the applications. So this is about your basic information of op amp and ideal and practical op amp characteristics, and the internal circuit, that is equivalent circuit diagram of the op amp, and the op amp characteristics. So in op amp we are having both DC and AC characteristics, and we seen already 741 op amp and its features, and the modes of operation in inverting and non-inverting, and basic applications of op amp. So it can be used as a instrumentation amplifier and the AC amplifier, or voltage to current converter, or current to voltage converter, or it can be used as sample and hold circuit, and multiplier and divider, differentiator and integrator, comparator, Smith trigger, multi vibrators, and it can be used as a voltage regulator. So these are all our applications of the op amp. We can use the op amp in so many applications. So that's why it can be that's because it has a high gain direct coupled amplifier, high gain direct coupled amplifier. So this is about your basics of integrated circuit. So I will share another. Slide. So you will clearly understand what is op amp and so and so information. That is another slide of the op amp is. So here also we are having the operational amplifier introduction. So the introduction of the op amp is so it is already we seen direct coupled and op amp. The operational amplifier is a versatile device that can be used to amplify DC, AC as well as input signals, and was originally designed. And the characteristics of op amp, so very high differential gain, high input impedance, so and so op amp symbol, this one non-inverting and inverting amplifier, and the basic information: two input terminals and one input terminal, and two power supply terminals minus VV, and the block diagram of the op amp. So we have already we discussed each and every stage and how it will be acts like as a differential amplifier. So these are again, so we'll discuss one by one in next. Already we discussed output, open loop, closed loop, inverting amplifier and non-inverting, so and so. So these all are so with the diagrams we discussed. It is a theory part of the op amp, theory part of the op amp. So we'll meet in next class. Thank you.